With functions in quotient format, there is a slight deviation from the procedure of determining the derivative when compared to polynomial equations. Learn about it here in differential calculus. Let's recall the general algorithm, which starts with the addition of deltas on both x and y. The next is to transpose y to the x expression, which eventually cancels out some terms. The third step is to inject delta x in the denominator, where more terms are reduced. And lastly, take the limit of the function as delta x approaches 0. The first example has y is equal to 1 over x plus 7, and the solution still starts with replacing y with y plus delta y and x with x plus delta x. At this point, there's not much to do, so transpose y to the other side. But remember that y is given as 1 over x plus 7 from the premise, thereby making the function the reciprocal of x plus delta x plus 7 less the reciprocal of x plus 7. Take the least common denominator to create a single quotient. Now the expression becomes delta y as equal to x plus 7 minus x minus delta x minus 7, all upon the quantity of x plus delta x plus 7 with the quantity of x plus 7. There are several terms from the numerator which can be cancelled out, leaving the equation to delta y as equal to negative delta x over the same denominator. With the function already simplified, divide it by delta x. And note that delta x in the numerator cancels out with the new denominator. So delta y over delta x is equal to negative 1 over the quantities x plus delta x plus 7 and x plus 7. Now place the limit as delta x approaches 0 into the function, and check that delta x on the first quantity on the denominator is zeroed out, so the limit becomes negative 1 over the quantity of x plus 7 with another quantity x plus 7. This we can simplify as the derivative of y with respect to x as negative 1 over the square of x plus 7. Example 2 is with the function y as equal to 2x over x minus 1. Plug the deltas by replacing x and y, and get y plus delta y as equal to twice of x plus delta x over x plus delta x minus 1. Distribute 2 among the terms and have y plus delta y as equal to 2x plus 2 delta x over x plus delta x minus 1. We can now transpose y to the other side, whereby y is equal to 2x over x minus 1. Delta y now becomes 2x plus 2 delta x over x plus delta x minus 1 minus 2x over x minus 1. Combine the two terms to have a single fraction by taking the least common denominator. So delta y becomes the quantity of 2x plus 2 delta x times x minus 1 minus 2x times x plus delta x minus 1. Both terms are over the quantity x plus delta x minus 1 times the quantity of x minus 1. Expand each of the terms to eliminate the parentheses and get 2x squared plus 2x delta x minus 2x minus twice of delta x minus 2x squared minus 2x delta x plus 2x. The denominator is also expanded into x squared plus x delta x minus 2x minus delta x plus 1. From the individual terms, 2x squared, 2x delta x, and 2x cancel out, leaving delta y with negative 2 delta x over x squared plus x delta x minus 2x minus delta x plus 1. The next step is to divide the function by delta x. So from the solved delta y earlier, we place delta x as its denominator, which cancels out delta x from the numerator. So the outcome is negative 2 over x squared plus x delta x minus 2x minus delta x plus 1. Now take the limit of the function as delta x approaches 0, and this will cancel out x delta x and negative delta x in the denominator. So dy over dx is negative 2 over x squared minus 2x plus 1. Check out that the denominator can also be compressed into the square of x minus 1. Example 3 has y is equal to 3x minus 1 over 2x plus 5. Begin by transforming the x's and y, and then expand the terms to take out the groupings. So y plus delta y is 3x plus 3 delta x minus 1 over 2x plus 2 delta x plus 5. Now transpose y to the other side of the equation, and plug 3x minus 1 over 2x plus 5 as y, to make the function delta y is equal to 3x plus 3 delta x minus 1 over 2x plus twice of delta x plus 5, then subtract y, which is 3x minus 1 over 2x plus 5. The two quotients should be coined together, so take their LCD. And because we have 3 terms to coin, let's break down the solution into parts. For the first term on the numerator, multiply the trinomial with the binomial to have 6x squared plus 15x plus 6x delta x plus 15 delta x minus 2x less 5. The only similar terms are 15x and negative 2x, making the expression 6x squared plus 13x plus 6x delta x plus 15 delta x minus 5. The remaining term on the numerator is next to be expanded, which results to 6x squared minus 2x plus 6x delta x minus 2 delta x plus 15x minus 5. Similarly, the only similar terms are negative 2x plus 15x, resulting to the expression 6x squared plus 13x plus 6x delta x minus 2 delta x minus 5. The terms in the denominator can also be expanded, where 10x and 10x are the only two similar terms. So the expanded form becomes 4x squared plus 20x plus 4x delta x plus 10 delta x plus 25. Place all the 3 terms in the delta y function and take out the parentheses. So the function becomes 6x squared plus 13x plus 6x delta x plus 15 delta x minus 5 minus 6x squared minus 13x minus 6x delta x plus 2 delta x plus 5 over 4x squared plus 20x plus 4x delta x plus 10 delta x plus 25. Many terms cancel out each other. They are 6x squared, 13x, 6x delta x, and 5. Reducing the function into 17 delta x over 4x squared plus 20x plus 4x delta x plus 25. Step 3 is to divide everything by delta x, which cancels out the delta x on the numerator, giving delta y over delta x is equal to 17 over 4x squared plus 20x plus 4x delta x plus 10 delta x plus 25. Finishing step 3, we move on to inject the limit when delta x approaches 0, and this takes out 4x delta x and 10 delta x from the denominator. So the derivative of y with respect to x is 17 over 4x squared plus 20x plus 25, which can also be compressed into 17 over the square of 2x plus 5.